All right, we're going to finish up the rest of these examples here. I'm going to go just a little bit faster through them so that the video isn't quite so long. You can always go back and look at them if you need to. Okay, but we do have some negative exponents now to look at. So this is 100 to the negative 1/2. And in the exponent rules videos at the beginning, I told you that if something has a negative exponent, you want to move it to the bottom of the fraction and make it positive. So for this one, I'm going to say 1 over 100 to the 1/2. Now, 100 to the 1/2, that's just the square root of 100. So now it says 1 over square root of 100. And we know the square root of 100 is 10. So this is just 1 over 10. Okay, 16 to the 2/3 times 16 to the negative 1/3. A couple of different ways that you can do this. If you want to go ahead and move the 16 to the 1/3 to the bottom of the fraction and then subtract the exponents, you can, but you don't have to. If you have something else that you're going to join with it, this is base to a power times base to a power. We're just going to add the exponents. You can go ahead and do that first also. So this is going to be 16 to the 2/3, and it's plus, right? Negative 1/3 is 16 to the 2 plus negative 1. Well, it's just 2 minus 1, which is 1. So 1/3. And that just, when I put it back into radical form, the number on the bottom is my root. So this is the cube root of 16. The cube root of 16 is not a nice number, so I'm just going to leave it cube root of 16. Okay, so this is negative 216 raised to the negative 1/3, and I don't have anything else to put that negative 1/3 with, so I need to move the negative 216 to the bottom of the fraction. So this is 1 over negative 216 raised, now it's going to be to the positive 1/3. So all I did was move it to the bottom of the fraction, but the negative 216 doesn't become positive. The rational exponent is what becomes positive, okay? See how this was negative 1/3? I move it to the bottom and it becomes positive 1/3. Does not affect this negative sign. Okay, so now this is 1 over the cube root of negative 216. I'm going from rational exponent back to radical form. And cube root of negative 216. Let's check it out. Okay, under math, I've got a cube root right there, number 4. So I can take the cube root of negative 216. And when I do that, I get negative 6. So you can check any of these numbers that you want to and see if they end up being a nice number or if they be a decimal. If they're a decimal, I want you to just leave them alone. Okay, don't simplify them at all. But if it ends up being a nice number like this negative 6, then we can go ahead and use it. All right, so this is 1 over negative 6. You can put that negative anywhere. You can put it in the top, you can put it out front, you can put it in the bottom. Okay, 112 over 7 to the negative 1/4. I need to raise that. This is a negative 1/4. So I can't just move it to the bottom of the fraction because I have a fraction that has a numerator and a denominator now. So what you do instead is you flip the fraction. So it's 7 over 112, all raised to the positive 1/4. So instead of negative 1/4, it's positive 1/4 because we just flipped it. So when I do that now, this one's kind of hard. There's a couple of different things you need to do. This is really like the 4th root of 7 over the 4th root of 112. Because both of these are 4th roots. They're both raised to the 1/4 power. So they're both of them 4th root. Unfortunately, we can't leave the 4th root of 112 in the bottom of the fraction, though. We have to do some simplifying there, and I don't think the 4th root of 112 is a nice number. Let me check it out real quick. Let me hit 4 and then go to my math and pick my random root and do 112. Oh, I did an extra parenthesis there that I didn't need to do. 4th root of 112. Yeah, it's a octadecimal, so I don't want to do that. So what I'm going to do is I'm going to multiply both parts by the 4th root of 112. Okay? Because when you do that, What that does is called rationalizing the denominator. So I'm going to go ahead and do that. I'm going to rationalize the denominator. And when I do that, in the top, I get the fourth root of 7 times 112, which is 784. And the fourth root of 112 times the fourth root of 112 is just going to give me 112. It's like the square root of 9 times the square root of 9 is the square root of 81, which is just 9. So the fourth root of 112 times the fourth root of 112 is it's like you can cancel out the roots in themselves and you end up with just 112. That's probably the hardest one on the page. All right, cube root of v times the square root of v. So if I put these both back into rational exponents, this one is v to the 1/3. This one is v to the 1/2. Now, base to a power, I add the exponents together. So v to the 1/3 times, plus 1/2. If I'm going to add them together, they both need a common denominator. I think I'm going to use 6. So to get this one to be a 6, I need to multiply times 2. To get this one to be a 6, I need to multiply times 3. So that gives me v to the 2 6 plus 3 6. Now I can add them. V to the 2 plus 3 is 5 6, which is the sixth root of v to the 5th. And I can leave it just like that. Okay, let's turn these guys back into rational exponents. This one is r to the 3/4. Okay, 3/4. This one is r to the 1/2. All right, I need to get common denominator, base to a power, I add. So r to the 3/4 plus 1/2. So this one needs a 2 down here. So I'm going to multiply by, a 4. So I'm going to multiply by 2 to get this to be a 4. So I have r to the 3/4 plus 2/4 is r to the 3 plus 2 is 5/4. And I go back into radical notation, and it is the fourth root of r to the 5th. Okay, a couple more examples here, and then we'll be all done with these. This is, I got to turn them back into rationals. Okay, I can't do anything like this like it is. But if I turn these back into rationals, this top one is just 4 to the 1st. The bottom is 4 to the 1/3. Okay, using my exponent rules, I would subtract the exponents. Okay, remember when they're multiplied, you add. When they're being divided, you subtract. So this is 4 to the 1 minus 1/3. And I can make that, I can turn this 1 into a 3/3 so that I can subtract. So 4 to the 3/3 minus 1/3. Guys, 3/3 is the same thing as 1. I'm just doing that so that they will have a common denominator. Now I have 4 to the 3 minus 1 is 2/3. Put that back into radical notation, and I have the cube root of 4 squared. Okay, and you can leave it like that. If you were to go ahead and put this as 16 and leave the cube root of 16, that would have been fine. I wouldn't have counted that wrong either. Okay, 7 to the 3/2 over 7 to the 1/2. I know that because I'm going to put them both back into radical notation. There are 2's, remember, over here, because it's a cube root. So 7 to the 3/2 divided by 7 to the 1/2. I subtract the exponents. So this will be 7 to the 3/2 minus 1/2. 3 minus 1 is 2, so 7 to the 2/2. Well, 2/2 is just 1. 7 to the 1st is 7. That one was easy. Okay, this says the fourth root of x to the 10th. Okay, so this is x to the 10/4. And 10/4 simplifies. Both of those numbers divide by 2. So this is x to the 5 over 2, which is the square root of x to the 5th. And we're done. Last one, this one says 25m squared to the 4th. So I think I want to do 25m squared all raised to the 1/4 power like this. And then break it up into the 4th root of 25 times, and this is going to be m to the 2 over 1 times 1 over 4 because it's power rule. Base to a power to a power. So you multiply them. So I have the 4th root of 25 times m to the 2 over 1 times 1 over 4. That's 2 over 4, which leaves me with the 4th root of 25. And this one is m to the 2/4, which I know m to the 2/4 is really m to the 1/2, which is really the square root of m. Because my directions said to leave them all in radical notation. So I needed to take that 2/4. 2/4 simplifies down into 1/2. And then when I turn that back into radical notation, that's just the square root of m. Okay, I want you guys to practice some of these in the Go Formative. Definitely something you need to practice because they're all just a little bit different. And refer back to these videos if you need to for examples.